Welcome to The Authority On, a podcast brought to you by Device Authority.
Good morning, good afternoon, good evening, depending on where you are. Welcome to the latest Device Authority podcast with myself, Paul Lockley. And with me today, James Penny, who is our CTO. No worries. Always good to spend time with you, James.
Mm-hmm.
Today, we're going to talk about how AI and ML can help improve the process related to SBOM. So for those that aren't familiar, let's do a quick recap on SBOM, which is software bill of materials. And really, this came to the form was driven by Joe Biden's executive order, EO 14028, which is mandating that companies provide a clear, updatable list of software components being used within devices. The point of that is to help understand where risk and exposure lies, and also to make people more accountable for the impact of substandard provision. Now, it's been through lots of phases from, we really do recommend this, it's best practice, to it now being enforced. Federal agencies, I think from September this year, will be mandating that you have a clear, definable SBOM process and can provide SBOMs related to the provision of devices and services. And for the FDA, I think it's October this year, they'll be mandating that all new devices have SBOM credentials. But when we start to look at that, it sounds quite straightforward. Provide an SBOM, provide a list of software. But James, from your point of view, as a technical person, a builder of things, how difficult is it? What's the impact of creating and maintaining an SBOM?
That's a really good question. I think I don't think it needs to be particularly onerous. I think there are already build processes. Lots of people are already doing, I guess, software dependency scans. And all you're really doing is effectively making sort of the output and of those scans and your list of components that you've created or imported during an engineering process available to others, which I think is a fair ask. I mean, one of the biggest problems really is importing something that you don't realize is a problem. And there's quite a few software tools that make that fairly easy for not only just the build stage, but also during the actual development stage. So like our engineers, for example, if they're trying to import a dependency, the IDE actually warns them and says that this particular version actually has some issues with it. So you want to make sure that you're using the right one. And we also have that secondary catch during the final build process of the entire project scan. So I don't think it needs to be particularly onerous. I think where it might catch one or two people out is if they suddenly start doing it, right? So if you get to the point where it's October and you start panicking or whatever, and you start scanning your software and creating SBOMs for your customers, then you might find it a bit of a hill climb to not only, I guess, go through all of the issues that you might have, but then does the big job of like updating all of those components to make sure they're no longer vulnerable. But so that initial piece might catch some people up, but the actual generation, it's an initial hill climb, and then it's more of an iterative process that if you have good practices, you can work your way through, and it doesn't have to materially impact, I think, any of your engineering timelines and things like that.
Yeah, so I guess what you're saying is if you leave it to the last minute, more the fool you. I mean, you could apply that to so many things. But with this whole concept of discovery, learning, and iteration, is this a great opportunity for AI/ML to step in and assist with that ongoing process. Know where the problem is, understand how to resolve it.
Yeah, it's an interesting one, and you've got a couple of different angles, I think, to really look at how things like artificial intelligence and machine learning intersect with something like software bill of materials. There's the idea of running those scans and trying to triage your dependencies against known vulnerabilities can obviously be helped by some of those processes. You can also have things like something that's quite interesting to think about is the idea of running, I guess, an example of your particular device in almost like a honeypot, or several of them. And then what you also could do there is if you look at what that particular device or software that device is running, using its SBOM, and you can recognize patterns. So if you have like several honeypots or devices all running the same software, and maybe there's some others that are running slightly different versions, you can start to actually figure out maybe where there's 0 days in your own devices, by trying to triage the SBOM that's running on the compromised devices against some of those attacks that are happening. So that type of thing is really good for I guess machine learning processes, because that's like pattern recognition, right? And if you have enough data, the machine learning is really good at finding those patterns and potentially stopping an attack against your devices or infrastructure or whatever it might be. And helping you triage what the source of that particular vulnerability might be. I think another way to also look at it is to include SBOM as part of a machine learning driven sort of authorization process. So if you're in our world, it's more device authentication, which is the identity, and then you try and figure out whether the device is authorized to be doing that thing. The inclusion of SBOM in that machine learning process for device authorization, again, can start to help figure out whether the device is running in a more authorized state, or guess what kind of trust level it's kind of operating at. If you can triage the SBOM against what the device is trying to do. Okay, it's generated a certificate or something. It's running an old version of OpenSSL, something like that. The key is maybe compromised or whatever. I think that's again is a really good sort of pattern matching process that I think machine learning really helps. And I guess the third one would be the actual enhancement of the integrity of data coming from those devices. So having a good SBOM with reduced or I want to say no vulnerabilities. I feel like there's obviously a scale between 1 and 10 of a score, but if you have visibility of the software that's running on those particular devices, you can make pretty good choices about the data that it's sending for your own machine learning processes, and whether you trust that data, and then you've got sort of a garbage in, garbage out result, I guess. So there's a couple of different ways I think in which they intersect, and SBOM's really adding that to the pool of data that can be used to achieve those various bits and pieces.
Yeah, and I think when we look at that, SBOM is a static instrument. When you apply the automation to that AI and ML brings, you start to be able to correlate activity and start to work out where potentially one of those vulnerabilities is being exploited and take remedial action. And remediation cures many ills. But you touched on something really interesting there. That enhanced trust of the device, because as you know, we have a wonderful view of trust the device, trust the data, and the data is the principal point of value. It's good oil versus bad oil in the engine. So I think when you take that concept of applying AI and ML to that, creating that automated sentinel within the system, you can start to make SBOM a more relevant part of an overall guardianship of your service, your infrastructure, your devices, and your data. So 1 + 1 = 3.
Yeah, absolutely. I think it's a really powerful bit of information to have. And I think the reason, and we're very focused on IoT, obviously, but I think it applies to various sectors. But I think the reason you do any of these projects is to get the data from it. That's the whole point, is to achieve, I think, scalable data collection for a lot of those processes and services. And what you do with it is completely up to you. But the idea is that you're collecting so much of this data, either computing it locally at the edge or shipping all of it back to some more centralized sort of cloud location. The integrity of that is imperative, and it affects an untrusted device, I think, almost spreads like a virus throughout that whole process, and will poison sort of the early stages of the stream or whatever that flows into a much bigger data river. So the knock-on effects are huge.
Yeah. A burglar only needs one open window, not all of them to be open.
Right. Right.
Yeah, and I think, when we look at that, the whole point of SBOM was to make people more accountable for things that are delivered. And, if you can find ways to broaden the visibility of vulnerabilities and automate as much of the process of remediation for that, everybody takes a step up with regards to this concept of zero trust, delivering a better place for everyone to operate.
Mm-hmm.
Well, look, as always, it's been an absolute pleasure spending some time with you, James. Thanks for your insight, and I look forward to the next opportunity to create a podcast and share our view on the very rapidly evolving landscape. Thank you, everyone. Thanks for listening. We look forward to speaking to you again soon.
Thank you for listening to this episode of The Authority On, a podcast brought to you by Device Authority. If you have any questions about the subject matter in this podcast, please head to the Device Authority website, deviceauthority.com. See you next time.